Have you ever pondered how the ancient civilizations made sense of the world around them without the advanced tools and technology we possess today? Imagine a time when the nighttime sky was not just a spectacle to behold, but a celestial canvas filled with mysteries and wonders. A time when the structures we built were not just feats of engineering, but also masterpieces of mathematics. In the heart of the desert, the Egyptians once looked to the heavens, aligning the pyramids, their timeless monuments, with the stars. But these structures were not just architectural marvels, they were mathematical triumphs. The Egyptians used basic geometry, a science of shapes and sizes, to build these colossal structures with astounding precision. Meanwhile, the Babylonians, nestled between the Tigris and Euphrates, were making strides of their own. They developed an early form of algebra, a branch of mathematics that deals with symbols and the rules for manipulating those symbols. This early algebra, crude as it might seem to us now, was a stepping stone towards solving complex mathematical problems. Across the sea, the Greeks were stargazing. They were the pioneers of astronomy, the scientific study of celestial objects, space, and the physical universe. They mapped the stars, named the constellations, and uncovered the cycles of the moon and planets. But their contributions didn't stop at the night sky. They delved into philosophy, asking questions about the nature of the universe and our place within it. These civilizations, each in their own way, were striving to understand the world around them. They were deciphering the language of the universe, without the benefit of the tools and technology we take for granted today. Their curiosity, their ingenuity, and their tireless quest for knowledge were nothing short of remarkable. These ancient civilizations, in their quest to understand the universe, laid the very foundation of what we now know as science and mathematics. Their legacy continues to echo through the ages, reminding us that our journey of discovery is built on the shoulders of those who dared to look up and wonder. Fast forward to the Renaissance, a period marked by a renewed interest in science and the natural world. But how did this era shape our understanding of the universe? The Renaissance, a span of 300 years from the 14th to the 17th century, was a period of cultural, artistic, and scientific rebirth. It was a time when the human intellect found itself unshackled, free to explore and question the mysteries of the universe. In this epoch of scientific reawakening, three figures stand tall: Nicholas Copernicus, Galileo Galilei, and Johannes Kepler. Their collective insights transformed our perception of the cosmos, shifting us from a geocentric to a heliocentric worldview. Copernicus, a Polish astronomer, was the first to propose that the Earth was not stationary at the center of the universe. Instead, he suggested that our planet was merely one among many, spinning on its axis and orbiting the sun. This radical idea, later known as the Copernican Revolution, challenged the long-held belief and laid the groundwork for modern astronomy. Galileo, an Italian polymath, further cemented the heliocentric model. He used his newly invented telescope to observe celestial bodies, discovering the moons of Jupiter, the phases of Venus, and sunspots. His observations provided empirical evidence that supported Copernicus's theory. Then came Kepler, a German astronomer, who proposed that the planets moved in elliptical orbits around the sun, not perfect circles as previously believed. His laws of planetary motion became the foundation of celestial mechanics. What made the Renaissance truly revolutionary, however, was the invention of the printing press. This innovation democratized knowledge, allowing the ideas of these great minds to be disseminated far and wide. No longer were scientific findings confined to the elite. They were now accessible to anyone who could read. The Renaissance, with its emphasis on observation and experimentation, truly marked a rebirth of scientific thought. It was a period where curiosity and skepticism were celebrated, where rigid beliefs were challenged, and where our understanding of the universe was forever changed. The Renaissance, in essence, was the dawn of modern science. As we journey into the age of Enlightenment, we encounter a new breed of scientists. How did these thinkers revolutionize our understanding of the world? This era, spanning the 17th and 18th centuries, was a time of great intellectual ferment. A spirit of inquiry gripped Europe, leading to a scientific revolution that forever changed our perspective on the universe. Among the luminaries of this period was Sir Isaac Newton, a mathematician, physicist, and astronomer. Newton's laws of motion and universal gravitation laid the groundwork for classical physics. He showed us that the same laws apply to the motion of celestial bodies and earthly objects, a revolutionary concept at the time. Newton's ideas provided a mathematical description of the physical world, a first step towards the predictability and precision we now associate with science. Around the same time, a Swedish botanist named Carl Linnaeus was revolutionizing biology. He developed a system for classifying living organisms based on shared characteristics. This became the basis for the binomial nomenclature we use today. Linnaeus's system made it easier to identify and study the vast diversity of life on Earth, sparking a new era of biological exploration. But perhaps the most significant development of the Age of Enlightenment was the establishment of the scientific method. This was a systematic approach to understanding the world, based on observation, experimentation, and evidence. The scientific method demanded rigorous testing of hypotheses and encouraged skepticism. It insisted on evidence and repeatability, making science a discipline anyone could learn and participate in. This shift from dogma to evidence-based inquiry opened up new realms of discovery. The scientific revolution of the Age of Enlightenment set the stage for all the scientific advances that followed, from the theory of evolution to quantum mechanics. The Age of Enlightenment, with its emphasis on reason and evidence, gave birth to the modern scientific method that we still use today. Now, let's leap into the 20th century and beyond. How have recent scientific discoveries reshaped our understanding of the universe? As we journey into the 20th century, we encounter a time of revolutionary scientific breakthroughs. Perhaps one of the most profound of these is Einstein's theory of relativity. This groundbreaking theory, proposed in the early 1900s, challenged conventional wisdom, suggesting that space and time are intertwined in a single continuum known as space-time. With this, Einstein showed us that the universe isn't as static and absolute as we once believed. Fast forward to the middle of the 20th century, and we see another monumental discovery: the structure of DNA. This double helix molecule, the blueprint of life itself, was unveiled by James Watson and Francis Crick. Their discovery paved the way for a deeper understanding of genetics and heredity, opening up new realms of possibilities in biotechnology and medicine. Now, let's take a quantum leap to the development of quantum mechanics. This radical branch of physics, born in the early 20th century, delves into the behavior of particles at the microscopic level. It's a world where particles can be in two places at once, and where observing a particle can change its state. Quantum mechanics has not only redefined our perception of reality, but also fueled technological advancements like semiconductors and lasers. And finally, we arrive at one of the most recent milestones in science: the detection of gravitational waves. These ripples in space-time, first predicted by Einstein a century ago, were finally observed in 2016. This landmark discovery has given us a brand new way to explore the universe, enabling us to detect cosmic events that were previously invisible. These recent scientific breakthroughs have not only reshaped our understanding of the universe, but they have also posed new questions for future generations of scientists to answer. Indeed, every answer we find only deepens the mystery, fueling our never-ending quest for knowledge. As we reflect on this journey through the history of science and mathematics, what can we glean about the nature of human curiosity and our quest for understanding? We've traversed the vast timeline of human knowledge, starting from the ancient civilizations, where the seeds of scientific thought were first sown. In those early societies, humans began to observe patterns in the world around them, laying the groundwork for the mathematics and sciences we know today. We journeyed through the rebirth of scientific thought during the Renaissance, a time of renewed interest in the natural world. This period saw the emergence of revolutionary figures such as Galileo and Newton, who challenged traditional beliefs and radically transformed our understanding of the universe. Our voyage then took us to the Age of Enlightenment, an era marked by the birth of modern science. This was a time when scientific discovery became a central part of intellectual and cultural life, leading to groundbreaking advancements in diverse fields, from physics to biology. We also unraveled the fabric of the universe, delving into the mysteries of quantum mechanics and relativity. These modern theories, though complex, provide us with the most accurate descriptions of the natural world to date, demonstrating the remarkable progress of science over the centuries. Throughout this journey, one thing has remained constant: our insatiable curiosity and desire to understand the universe. These qualities have propelled us forward, driving us to ask questions, seek answers, and continually push the boundaries of our knowledge. Indeed, science and mathematics are much more than just fields of study. They are a testament to our capacity for exploration and discovery, reflecting our innate fascination with the world around us. They challenge us, inspire us, and ultimately shape our understanding of the universe and our place within it. Science and mathematics, from their humble beginnings in the ancient world to the cutting-edge research of today, serve as a testament to humanity's unending quest for knowledge and understanding of the universe.